Howdy folks, I'm going to make this video today to try and repay the YouTube world for all the things that I've figured out how to fix, things I've figured out how to do, things I've learned on YouTube over the years, and try and pay it forward a little bit. What I have here is a 1970s technology Hardinge CHNC chucker lathe. And I've been doing some restoration work on it. I haven't done like ways or anything on it, but I built a new electronics cabinet and moved everything into there. I had to redo this whole X drive system. I had to put a new encoder in this thing. It's been retrofitted with a Fagor 8025T controller. I figured out how to do the pneumatics to get the turret to pop up and down. And now it can be manually indexed and locked back down with pneumatic air so that the turret's usable again. And now I'm up to, had to put a new rotary encoder on it. The rotary encoder was bad. And I'm up to working on the collet closer, the pneumatic collet closer. So what we're going to do is learn how to get into a Hardinge Vari-Grip Pneumatic Collet Closer. Okay, so here's what it looks like when you pull it out of the machine, except for this is mounted onto the spindle shaft. Actually, it's the collet closer tube here. It's just that this is put on with a light press fit, and I didn't want to put it back on there just for the purposes of this video. But otherwise, that's how it looks when you get it out of the machine. This is the collet end, standard 5C collet, goes threaded into this end, and this is the Hardinge Vari-Grip registered trademark. And when I went online to try and find out some information about this, surprisingly there's not a lot about this Vari-Grip collet closer online. There's a little bit of information on Post and Practical Machinist and CNC Zone, but not a lot. And the one thing that I did see was everybody complains about the air leaks in this, and I suspect that that's coming from this. Now I got one of the bearings pulled out. That bearing right there is bad, and I pressed it out of here. But you see this brass sleeve, and there's channels cut in there. That's where the air flows from the air tubes that come up from the solenoid valves, and they flow into this spindle tube here through the ports here, and there's one on this side there. And then the air, this is actually a sleeve that's pressed onto the threaded portion down there, and in that threaded tube there's keyways cut to take the air into this piston onto either side of the piston, and one's open and one's closed. So what I ended up finding that helped me was some drawings that I actually had the original drawings that came with the machine of the Vari-Grip collet closer system. You can see it's the Vari-Grip 3000 RPM 5C tapered, and it's got a parts list that goes with it. And in order to figure out what's going on with this thing, because I got stumped, and we'll talk about that in a minute, to try and figure out what it was, I blew this drawing up and I color coded it so I could see which parts were what, and we'll talk about that here again in a little bit. So to get into this thing, first thing I did, and first thing you got to do, is you have to take this spindle nut off. And I played hell trying to get into the spindle nut. The pinholes that were in there were all wallered out, so the first thing I did was I drilled them out to 1/4 inch, and I found some 1/4 inch dowel pins, put those in. My plan is to make a wrench for this. I just haven't gotten to it yet, but I just used a pry bar between these to spin that off. And it is a fairly tight fit. It's got a fit like a lock nut on it, which I think is on purpose to keep it from backing off. So it does take a fairly healthy force to roll that thing off of there and put it back on again. So once you get that off, then I pried this air gland system off of there, and what I did was I just started in this groove right here. There's enough gap right there from that shoulder to get a couple of small pry bars in there, and you can pry against this casing a little bit. You don't want to get on it with anything crazy force, but if you just gently pry both sides evenly and squarely, you can get this thing to move back. And then once you get enough room, you can get the fingers of a gear puller in there. And I also added some washers down in there on top of this end of this tube so that the gear puller had something to push on against. And then slide it up off of there. And it comes off. Talked about the glands in here and the brass on steel fit. There was a lot of complaints about the air leaking in this system. That was the one thing I read about on Practical Machinist and CNC Zone. And I believe that's where this comes from, because this is it's a light press fit with this brass sleeve, this brass bushing or whatever you want to call it on this steel sleeve right here where the air transfers into there. And there are no sealing surfaces in there. They are just brass on steel. And this is an oiled system. Every 10 minutes there's a lube oil timer in this old Hardinge lathe. And the whole thing was used with regular oil, cutting oil, and that oil was also, it got everywhere, but there is a light machine oil system on there, so every time it lubes the ways, it also shot lube oil into the pneumatic lines that go to this, so there was a lot of oil all in here that is probably 20 years old. Anyway, once you get this this guy off, the next step in the process is to remove these socket head cap screws around here. I've got them all out except for one for demonstration purposes here, and to shorten up the video so you don't watch me operate an Allen wrench. You pull out those socket head cap screws, and then this aft housing will pull off of here, and you can slide it back off of here. So I got into there, and then what you see here are check valves and some relief pistons. This is the check valve here, and this is what I'm calling a relief piston. I don't know what you really call it, but I can show you this better on the diagram how this works. So on this diagram here, the orange part is the piston, and this is the relief piston and the check valve, and a relief piston and the check valve. And the way this works is when the air comes into one side, it goes in, pressurizes the cavity, and moves the piston, and that air gets trapped in that gland and can't get out by this check valve. Let's say it pressurizes this cavity in here, pushes the piston, and this check valve is an O-ring here, and it seals that cavity up, and that air actually gets trapped inside there and it can't get out. So you can actually remove the air from the system at that point, and it will stay closed or open, whichever way's which. Then when you go to pressurize the other side to open it or close it, vice versa, whatever you're at, the air will come into this gland on this side. It'll push on this piston right here. There's O-ring seals right there. It's a little piston with a little pin that comes down, and it actually pushes the check valve on the other side away from the sealing surface, so that the air can escape back out the passage and be exhausted out to relieve the pressure. So it's kind of a flip-flop system, and whenever you're pressurizing one side, the piston on that side pushes in and opens up the check valve on the other side to exhaust and relieve the pressure. So that's how that works. So I removed that, and I took a look at this thing, and I'm like, okay, how do you get into it now? I couldn't get the outer housing to move very much. I could get a little bit of movement if I squeezed here between these two, and other than that, I couldn't figure out how to get the thing apart. So I did notice on this side that there was a shoulder cut into that spindle tube, into that collet tube, and I didn't want to grab a hold of this and crush it, so I figured it'd be better to get a hold of it here, but this was round, and anything I tried to clamp it in, it would just spin. So I ended up putting this in my super spacer, and I flat-sided on 3 sides so that it would go easily into a 3-jaw chuck into my super spacer, and then I could get a hold of it better, but I still couldn't get the thing off. I figured that this had to thread out of here somehow, but you can't grab a hold of anything in here because it's all sealing surfaces. There's an O-ring that seals on this surface. The piston doesn't really seal, but the insides of these passages are sealed, especially on the piston side. The bigger one's the piston side. And there's a sealing surface in the bottom of the check valve side. There is an O-ring that seals onto this shoulder, and then you've got the brass sealing surface on here, and where the bearings for the gland passage to go on here. So short story is you can't really pry on anything here because you don't want to mar up the surfaces. So my first attempt was to hand cut these with a file. I put some square keyways in there basically so that I could grab a hold of it with a flat piece of steel and try to crank it off of there, but I couldn't get anything to move. I couldn't get it to come off. It just wasn't a good way to get a hold of it. So I went to the drawing again, and I figured out that I was kind of fighting myself a little bit, because this drawing, you see this brown portion here represents the shoulder with the set screws in it, and it said there's a little brass plug in there. And then when I saw that brass plug, I'm like, the only reason you have a brass plug is if you're trying to push against some threads. And then I saw that there was threads in there, so then I knew that this spindle system had to thread out of the other part of that tube. So I was on the right trail. I just wasn't quite far enough along or getting there fast enough. So I then looked at this, and I knew that the outer housing wouldn't rotate, so that the outer housing had to somehow be attached to this this sleeve and the red part. And it turns out they are all in one piece. So I could have tried to get into these smaller, I think they're number 10 socket head cap screws, but I didn't want to break one of those off in there. It'd be a bugger trying to get it out of there. I guess I didn't have a strap wrench, but I could have tried to get a strap wrench around this thing. And turned out the easiest way for me was to make a tool, and this is the tool that I used. Now I didn't want to mess up those sealing passages here, so I made some aluminum sleeves. One fits in the big one fits in the smaller one here, and that way I wouldn't mar up those surfaces. And then I just fashioned up this plate, put a 7/16 bolt and a 1/2 inch bolt in there, and welded a handle onto it. And then that fit into here. And when I did that, let me set you up here so that you can see what I'm doing while I'm taking this off of here. But after I did that, then I could get a hold of this thing, and I could, first of all, you gotta make sure you turn out all the set screws. I actually have 2 of them removed, and this one I'll just loosen up. And then you can spin this thing off here, and I was able to get a hold of it. I pinched it in my super spacer in the 3-jaw chuck and got a hold of it, and then it comes along, and there, lo and behold, is the thread that I was hoping that would come apart, and it did once I had enough leverage and enough way to get a hold of it. So with that removed, let me take my little aluminum bushings out of there, and now we're a hold of this thing, and now it's a simple matter of just grabbing the center spindle piece here, pushing with my thumbs and pulling on the housing, and then the piston will come up out of the housing. And I'll pick the camera back up here in a second and show you what I got. So there's the inside of the housing. They fell out of there when I unbolted it, but here's the check valve and the depressurizing piston from the back side. Notice the same ports in the back side, and then there's one hole here that registers against this dowel right here so that this can't rotate around the piston. It's all kind of locked in one position. But that's it. The piston is held onto that shaft by that nut right there. I see no reason to take that nut off of there and try and get that piston off of there. I imagine that there's an O-ring in there that seals the airflow between the sides of the piston, but there's no relative motion. it's, you know, it's just a static O-ring that's probably in there, and I see no reason to go in there and try and get that out of there. Even though it's a 40-year-old O-ring, it's probably, there's oil in there, and it's probably very well pickled and preserved, and I ain't gonna mess with it. So that's the piston. Now, the sealing surfaces here, let me gather up my parts. Here's the little check valve that holds the air pressure either on the open side or the closed side. And I can't get my camera to focus on my hand there, but there's an O-ring that's pressed in the end of that little check valve. It's a brass check valve, and there's a little O-ring. There's a little, not a boss, but a little pocket cut in there. And that O-ring is pressed in there, and then it's held in just by simple spring pressure with just a little bit of spring pressure. Then, when you pressurize the other side, it pushes on the back of this piston, pushes on the inside of that little check valve, and relieves the pressure off of that side, and that's how that works. So I'll gather those pieces up. Now there's O-rings on here. I have them removed. I got to get them. I was able to go on. McMaster car would have had all this. That bearing was bad. I had to remove that bearing. I pressed it out last night. That's it right there. And the piston has two quad rings that go on it. It's a double quad ring system. And McMaster car had those, but you'd have to buy 10 of them each, or a pack of 10, which I get 2 out of. And then this big O-ring seals on the back side of the aft housing there, and it's just a regular 332 O-ring, 5 3/4 inch ID. And I think I would have had to buy a pack of 25 of those. And then there's two different sizes of quad rings here. The bigger one goes in the aft housing where the other O-ring just was. It seals the ID bore on that. And then the smaller one goes on to the front housing that faces the machine and seals on the spindle in there. So basically, to rebuild this thing with new seals, you're looking at 4 quad rings, a big O-ring, 2 small O-rings, and 2 even smaller O-rings to replace them that go into these ends. So the small ones I forgot to order, but I think I can just get those at Ace or Tractor Supply or something like that. But anyway, that's how you get into this bad boy. And once you know the secret, it's not really all that hard, but it's figuring out what you don't know to start with. I'm hoping that this helps somebody that may have to rebuild one of these in the future. After thinking about it, you wouldn't have to do this wrench. I believe that if you grabbed a hold of this forward housing here, because of this dowel pin right here that seats into the piston right here, I believe that you could, if you can get a hold of this shaft either here or here somehow and get a strap wrench on the forward housing, turn it around here so it's facing the way that it should be. I believe that if you got a hold of this and this was all assembled, I believe you could put a strap wrench around here and probably get that to spin off once you loosen up the set screws in that shoulder right there. And that'd probably be the only thing that I would do differently. Oh, I forgot to mention too, I did have to put some heat on this spindle nut. Not a lot, but I put a little bit of heat on this spindle nut to get that thing to come loose because I couldn't get it to loosen up. And I just used a little butane torch, not a full-on acetylene system. I just used the butane, put a little bit of heat on it, right on the nut to get it to open up on the threads just a little bit, and it did help. I was able to turn that off of there with a little more ease. And I may heat it up before I put it back on just to help me get it threaded on there most of the way before it cools and shrinks down onto there. But hopefully this helps somebody that has to rebuild one of these Vari-Grips in the future, and you won't have to learn. Your learning curve will be a lot shallower than mine was because I had kind of a steep one, and I played hell getting a couple of these pieces apart. But anyway, thanks YouTube, and I hope this helps pay it forward a little bit, and I hope if anybody's watching this, it helps you rebuild your Vari-Grip collet closer. Take care.